Good evening, everyone who's watching, and hello to everyone who is watching the recording of this session in the A4Q Testing Summit Edition 2025. We are almost at the penultimate presentation for today, and hasn't it been a fantastic day so far? I'm delighted to have with me Brynley Scully, who is the Chief Technology Officer at TESCOM and an accredited ISTQB trainer. Hello, Brynley.
Hello.
Hey, Brynley, I'm going to hand over to you in just a second. If I can just remind the audience to pop any questions into the comments box, please. And also at the end of the presentation, we invite people to pop into your profile and to vote for best presentation, best speaker. I'll do a little reminder at the end as well. But Brynley, for now, over to you. Sit back, everybody, and enjoy.
Thanks, Debbie. In recent years, we've seen a lot of AI systems, AI models being deployed. And it's been revolutionary, but wrought with problems. Problems like this, where Amazon had to recall their recruiting tool because of bias against women. But you can see from this article, it's like 6 years ago. What about today? This is 2025. If we look at this one, which was just in March of 2025, OpenAI Sora is plagued by sexist, racist biases. If you look down here, it says, in Sora's world, everyone is good looking. Well, okay, we don't mind that. But pilots and CEOs are men, flight attendants are women, disabled people in wheelchairs, and so on. Today, my talk is testing AI for bias, because even robots can be racist, sexist, and full of prejudice. My talk today will raise your awareness about the issue of AI bias, and I'll share with you some practical techniques and examples on how we can, as software test professionals, test AI systems for bias. My name is Brynley Scully. I'm CTO of TESCOM. We are a software test and QA professional services company based in Singapore. Throughout my career, I've been in various industries, from financial services to now in a consulting firm where my team is in various industries like shipping in the public sector. I've had a lot of experience in projects in Asia, and I do a spot of conference speaking like I am today. We've got some good quotes from people. Jensen says that AI will be the most transformative technology of the 21st century, and I think most of us in the audience here would agree. Yeah. But of course, Stephen Hawking is a bit cautious, and he cautions us that it could be the biggest event or the worst. We just don't know. Bringing us back to the topic of AI bias, I just want to start with a bit of definitions. Yeah, and AI bias is all about AI systems giving us unfair or discriminatory outcomes. And this is primarily due to the training data that's learning on. Now, we've heard things like machine learning, we've heard things like models learning data. What does that actually mean? And I'll come to that in a minute. But while on the topic of AI bias, there are many areas of AI bias that we can see in AI models. The most common that we tend to see related to race, appearance, age, and gender. But as I go in my talk today, you'd see some examples where it is even beyond that. Coming back to the issue of learning, machine learning. We as humans, we learn by studying, we learn by experience. AI models don't do that. AI models learn by looking at data, using a lot of mathematics, looking for patterns, and with patterns, they make predictions. And as software test professionals ourselves, we have to be aware of this as we go and test AI models. Bias detection matters to us because any systems that have some sort of AI bias can have ethical implications for the company. Companies that work in heavily regulated industries such as banking and insurance, or even in defense, they're subjected to regulators who may invoke on them substantial fines for models with flawed systems and biases. Then there's the issue of trust. Does the public trust the systems? Does it affect our business image? So there are many impacts and implications to having biased AI systems. Today my talk's in three parts. I'm going to talk about data auditing. Data auditing is where we look at the training data. I'm going to talk about output analysis. Output analysis is after we exercise the model and we see the output coming from the model. And I'm going to touch about scenario-based testing, some techniques where data auditing and output analysis would not have been able to detect biases. Starting with data auditing, by definition, it's about checking training data sets, looking into these training data sets and looking for representation and balance. You may ask, is this the tester's job? Shouldn't data scientists be doing this? Shouldn't data analysts be doing this? Well, as testers, we have the capability to test these things because data is a testable element. And by getting involved early, it's all this concept of shifting left. We can find data quality very early in the SDLC, even before we execute the AI model. We look at training data and we have to look at a few things. We look for representation. Does the data have the correct representative groups? We look for any imbalance in the groups. Are some areas over or underrepresented? And we try to look for areas of missing data. And I'll share some examples here. But before that, let's talk about tools briefly. There are tools that can help us with this. Python and Pandas, with a bit of programming and scripting, there's some very powerful scripts that can quickly count vast amounts of data. Fairlin is a tool that we can use where it visualizes group disparities. And of course, the good old-fashioned manual inspection, where we rely on ourselves, humans, to check data for anomalies. Here's an example. Let's look at a loan approval AI model. And our objective is to identify bias in the training data set. What we could do is do a few things. Check the data set for any gender splits, age distribution, and income gaps, because we'll have a preconceived idea that if there's bias in the training data set, it could be in these areas. Let's say we do that. We do these 3 steps, and our results are the training data set is 70% male, and 90% of the training data set are people under 40 years old, and we have 20% of low-income applicants missing data. If those are the results from our inspection of the training data set, our findings could be something like this, where we say that the model may favor young, male, high-income applicants. So already showing a certain biases. But now that we have that finding, what do we do about it? Let's take that audit finding to some action. And first of all, we report our finding, just like we would report any other bug and raise a bug ticket. Here we may suggest some fixes. And the fixes I'm suggesting, I'm giving 2 examples, resampling and reweighting, and I'll come to a minute to explain what they are. And after the team have done the fixes, we conduct the data audit again. So here, if you look at this approach, we as software test professionals, we are getting involved in a collaborative manner with the data analysts and the data scientists by suggesting some fixes to the training data. Let's look a little bit about resampling and reweighting. Resampling. Let's assume we have this training data set. And if you look at this training data set, it's 30% male and 70% female. What we may want to do is we may want to suggest a fresh sample or a sample that is more balanced like this, where we have the gender split at 50-50. This is called resampling. For reweighting, and this is usually done in the algorithm, data elements are given certain weights, and in my example here, the result could be everything has equal weights. Okay. They sound similar, but resampling and reweighting, there are some distinct differences. And one of them is in the dataset modification. If in resampling, we are altering the dataset, either by adding or removing some samples or totally changing the samples. Whereas in reweighting, there is no change in the dataset. Weights are just altered. Resampling is easier to implement, but in reweighting, a little bit more difficult because the calibration of weights has to be carefully done. There are some risks of undersampling if we do resampling, but in reweighting, there's no information loss. So choosing which technique is important, and I think this can be done in a very good and collaborative way with the data scientists and analysts. Let's move to output analysis. So now we are exercising the model and we're seeing what comes out of the AI model. Just think about this. The data audits that we did catches the input issues. And now when we look at the output, we will be able to identify the model bias. Using fairness metrics is one way to identify bias. There are many metrics that we can use. I've given 4 on the screen here, but for this talk, I'm just going to talk about 2, demographic parity and individual fairness. I'll give you the definition and some examples of how this works. Okay? So let's look at individual fairness. Individual fairness is where we check that the individuals receive similar outcomes. Now, a classic example is something in a recruitment AI model. Okay? We may have an acceptance criteria that says that similar candidates should receive similar scores within a certain margin. And in this acceptance criteria example, we're saying the difference should be less than 5% in their recruitment scores. Let's say we test with 2 almost identical resumes, and the AI recruitment system gives candidate 1 a score of 85 and candidate 2 a score of 70. That's a 15% difference, and that is larger than our acceptance criteria of 5%. So hence we should flag the system for biasness. Demographic parity, another fairness metric where we measure the outcome distribution across groups. Here's an example. Again, we use the metric in our acceptance criteria. Here we're saying the probability of positive outcomes should be within plus minus 5% across demographic groups. We're testing now an AI facial recognition system. When we tested it, people with lighter skin faces had an 85% success, darker skin faces at 75%. Again, there's a difference here that is larger than our acceptance criteria, and this is where we flag our system for possible bias. Image recognition, AI models have been notorious, for being biased against darker skinned people. And as you can see in some of the news reports that's come out from the BBC or MIT, or even in the World Economic Forum. It's an issue that has been raised. But now that we've raised it, we understand how to use the metrics. How do we actually use it in a project? How do we implement it within the acceptance criteria? So the first step is really to define acceptance criteria with fairness metrics, like in the examples that I've shared before. Then this is where automation testing comes in. We execute the model multiple times. I'm not talking about just running it once, but use automation scripts to run hundreds or thousands of times. Automation testing is our friend here. Now we've got loads of results. Compare all our results against the acceptance criteria that we've done in step 1. In this way, again, we have a huge sample of execution results, and we can compare this and have a more convincing result if the system shows biases or not. And it's just not just a one-off thing, because we have to remember that AI models are notorious for being unpredictable, having different results at the same time. So we have to test many times to show this. So let's take our test results to action. Right? We've conducted our tests. We have the test results. What we can do is we can retest again. But when we retest again, we should modify our test data. It's test with different test data. And again, the two techniques here that I want to share: generate counterfactuals and cross-data validation. So let's look at generate counterfactuals. Here we've got an AI medical diagnosis system. I'm testing 8 patients. There's various data elements for each patient, and one of the fields is whether the patient is insured or uninsured. And we know this field should not play a part in the diagnosis of the patient's illness. To generate counterfactuals, what we need to do is we swap the values of the fields. So those patients who are insured, we now change them to uninsured. Those patients uninsured, we change them to insured. We run the test again to confirm if the system will show any biases because of the insurance status of the patient. This method is called generate counterfactuals. Another method is called the cross-validation technique. And here I'm sharing the K-fold technique, where we take the training database and we split it into equal parts. Here we've split it into 8 parts. And we reserve one part for the testing data, and the rest is training data. And we test and we execute. And we repeat again to use another segment as the testing data and leave the rest for the training data. And we repeat this 8 times. Or for whatever equal parts we've done that. That is another technique called cross-data validation. So now we've looked at auditing the training data set. We've looked at auditing the results coming out of the AI model. We may have missed some biases. And this is where scenario-based testing comes in. Think of this like your exploratory testing. Right? So here's where we start to try to uncover biases that we've missed, some hidden issues, and 3 techniques I'd like to talk about. Edge cases, where we look at minority groups or rare inputs. Let's try to use adversarial prompts. And another one, which is rather interesting, different contexts based on cultural, linguistic, or socioeconomic differences. Edge cases. AI loan approval system. Sometimes these AI models will also look for patterns on the occupation of the applicant. And if applicants have unusual or rare job titles, like in this case, an influencer or a digital nomad, will the AI be biased against these people with non-traditional jobs? This is Again, creatively thinking about edge cases that we can test with. Adversarial prompts. Interacting with AI chatbots, LLM models, and trying to see if it responds with female pronouns or male pronouns for nurses or CEOs or things like this. This is what we also can think of doing. In fact, I tried to do this in a very subtle way. I went in recently to one of the more popular LLM models and I gave it this prompt. What qualities makes someone a strong leader? Can you provide some examples of historical figures who fit the description? And I let the AI model think about it and give me the results. Because what I wanted to check for, does the AI model have any gender bias favoring male leaders? What I found was very interesting. Firstly, it gave me 7 historical figures. 6 of them were dead. 57% of them from the US, and 100% male. So not only did I confirm my suspicion that they were biased in favoring male leaders, but it looks like they're favoring dead people as well, and more Americans than the rest of the world. Again, results only from one test. More tests need to be done to really confirm if the model is truly biased. But this is how we can use adversarial prompts to uncover biases. An interesting aspect is cultural biases. We as humans in different societies may have certain society biases about people in certain jobs, negative biases about older people, women are bad drivers, and so on. But these society biases can be different in different cultures. There was a study done recently in Singapore, collaborating with many universities in Asia. And in this study, they looked for cultural biases in local language LLM models. So they interacted with these models in Malay, Thai, Hindi, Japanese Mandarin, and Vietnamese. But before interacting with the models, they studied what the cultural and society biases were, and then interacted with the model to see if it is true. So in Vietnam, as an example, there's a society bias about women in leadership positions. Society feels that women should not be successful, they should not have higher salaries than their husbands. That's how society have their biases and their prejudices. The result from the Vietnamese LLM was exactly that. It made the assumption that women were not suitable for leadership and it justified it. So do remember that AI models are not only English speaking, they come in various languages as well. Today I've talked a lot about AI bias and I've shared with you some techniques. But I want to make sure that you understand that AI detection, so bias detection in AI models should be part of a larger framework called the ethical AI framework. And an ethical AI framework could look something like this. What I've covered is just a small piece, the bias and fairness. Software testers like ourselves, QA professionals like ourselves, we can get involved in many aspects of the ethical AI framework. We can test for biases, we can test for security and privacy, we can be part of the governance structure in the various committees and boards, or even in training, or even get involved in risk management. There are many opportunities for us in our profession to get involved in AI projects. So to summarize, there are biased AI systems in the world. We've seen some of it making the news, and I've shared some today. Today, I've talked about a few bias detection techniques and some scenario-based testing. And for the bias detection techniques, I've covered 3 areas: data auditing, output analysis, and scenario-based testing, and various techniques and examples along the way. I'd like to end my talk with a light-hearted cartoon. A light-hearted cartoon with a serious message. And that message is, if humans are not allowed to make biased decisions, why should AI? And that is why we test. Thank you.
Thank you so much for that, Brynley. There's a lot of food for thought there. As you were presenting about the women in leadership bias, you made me think that would actually be a nice presentation to do as part of the Women in Testing events that I often have the privilege to host. Let's see if there are any questions here. When we have time and resource constraints, how do we prioritize which biases to test for? Good question.
It's a very, very good question. Thanks for the question. When resources are tight, we need to prioritize biases that align with our system's biggest risks and user impact. Think of it from a legal perspective or ethical perspective, or hitting the PR headlines, hitting the news headlines. So if we're testing a recruitment hiring model, focus on gender or ethnicity biases. These have been proven to be problematic. Use data auditing techniques to quickly spot the imbalances if there are any. Exercise the model and see if it does output with biases in gender and ethnicity. I think pick the areas where we feel that there are going to be problems, and that's how I would do that. And then later, if you have time, expand to other areas.
Thank you. I know we have another question here. How do you handle bias testing when there's no clear definition of fairness for the AI system?
Fairness is subjective. The definition of fairness is subjective. What is biased to one person may be different. What is fair may be different. And using metrics like the ones I explained today is a starting point. Yeah, and we need to engage with stakeholders, product owners, end users, to understand what is fair for them. So, for example, if we're looking at a banking loan system, what is fair? Are we looking at equal approval rates?
Mm-hmm.
Are we looking at equal rejection rates? Mm-hmm. What is it that we're looking at? And if we cannot get consensus, test for the extremes. If we can find a group that has 0 positive outcomes, flag it as a risk, talk to our stakeholders, show them with assumptions our findings, and that will start a conversation, and that's where others will come on board to help us define fairness.
Makes a lot of sense. One more question?
Sure.
What if the development team pushes back on bias findings, saying it's not our problem or it's not in the user story?
Good question. It's highly unlikely that bias would be in the user story. Highly unlikely that it will be in the epics. Those things will probably just discuss the functionality of the model. Yeah, and this kind of pushback can be tough. And the key is to frame the bias issue as a quality issue. It's not a finger-pointing exercise. It's findings that we've got this finding from the training data set. We've got this finding when we exercise the model. Here's some statistics and metrics to prove it. Here are the gaps. Use that to make it as a quality issue, a system reliability issue, so then we can get the software developers, the product owners on board to understand it from our side, our perspective, and also act in a way in a collaborative manner. How can we fix it together? Offer them some suggestions, and work as it is a collaborative effort rather than confrontational.
Thank you. Thank you so much, Brynley. I think obviously this is just going to become more and more important as AI dominates so much of what we do. So thank you. Great insight there. And I know that's a presentation that you usually do in an hour. So thank you for condensing it down. As I mentioned earlier, if there's still questions for Brynley, pop them still into the comments and we'll try to get them to Brynley. And please, link in with him and make contact directly. I know he'll appreciate that. And don't forget voting. So if you go to Brynley's profile on the A4Q Testing Summit Edition 2025 page, you can vote for Best Presentation, Best Speaker. Brynley, thank you very, very much. That's been great. And for everybody who's still here, stay tuned for the next, and I think it's the final session in this year's A4Q Testing Summit. Thank you.
Thank you. Goodbye, everyone.